Unit 1 Foundations of HCI. Topic 1 The Human Input Output Channels. So these are the topics comes under input output channels. We will see one by one. The human. The user is after all the one whom computer systems are designed to assist. The requirements of the user should therefore be our first priority. In 1983, Cord, Moran and Newell described the model human processor, which is a simplified view of the human processing involved in interacting with computer systems. The model comprises three subsystems: the perceptual system, the motor system, the cognitive system. Perceptual system handling sensory stimulus from the outside world. Motor system which controls actions. Cognitive system which provides the processing needed to connect the two. Next, input-output channels. A person's interaction with the outside world occurs through information being received and sent, that is, input and output. In an interaction with a computer, the user receives information that is output by the computer and responds by providing input to the computer. The user's output becomes the computer's input and vice versa. Input in the human occurs mainly through the senses and output through the motor control of the effectors. There are 5 major senses: sight, hearing, touch, taste and smell. Of these, the first 3, that is sight, hearing, touch, are the most important to HCI. Taste and smell do not currently play a significant role in HCI. There are number of effectors including the limbs, fingers, eyes, head and vocal system. In the interaction with the computer, the fingers play the primary role through typing or mouse control with some use of voice and eye, head and body position. Example: imagine using a personal computer with a mouse and a keyboard. The application you are using has a graphical interface with menus, icons and windows. In your interaction with this system, you receive information primarily by sight from what appears on the screen. However, you may also receive information by ear. For example, the computer you may beep at you if you make a mistake or to draw attention to something. Or there may be a voice commentary in a multimedia presentation. Touch plays a part too, in that you will feel the keys moving or the orientation of the mouse, which provides vital feedback about what you have done. Next, vision. Human vision is a highly complex activity with a range of physical and perceptual limitations, yet it is the primary source of information for the average person. Visual perception can be divided into 2 stages: the physical reception of the stimulus from the outside world. Next is the processing and interpretation of that stimulus. Next, human eye. Vision begins with light. The eye is a mechanism for receiving light and transforming it into electrical energy. Light is reflected from objects in the world and their image is focused upside down on the back of the eye. The receptors in the eye transform it into electrical signals which are passed to the brain. So this is the common human eye diagram. First, we'll see cornea and lens. Cornea and lens at the front of the eye focus the light into a sharp image on the back of the eye, the retina. The retina is light sensitive and contains 2 types of photoreceptor. One is rod and another one is cones. We will see about rods. Rods are highly sensitive to light and therefore allow us to see under a low level of illumination. However, they are unable to resolve fine detail and are subject to light saturation. This is the reason for the temporary blindness we get when moving from a darkened room into sunlight. The rods have been active and are saturated by the sudden light. The cones do not operate either as they are suppressed by the rods. We are therefore temporarily unable to see at all. There are approximately 120 million rods per eye, which are mainly situated towards the edges of the retina. Rods therefore dominate peripheral vision. Cones. Cones are the second type of receptor in the eye. They are less sensitive to light than the rods and can therefore tolerate more light. There are three types of cone, each sensitive to a different wavelength of light. This allows color vision. Next, fovea. The eye has approximately 6 million cones mainly concentrated on the fovea, a small area of the retina on which images are fixated. The retina is mainly covered with photoreceptors. There is one blind spot where the optic nerve enters the eye. The blind spot has no rods or cones, yet our visual system compensates for this so that in normal circumstances we are unaware of it. The retina also has specialized nerve cells called ganglion cells. There are two types, one is X cell and another one is Y cell. X cells, which are concentrated in the fovea and are responsible for the early detection of pattern. Y cells, which are more widely distributed in the retina and are responsible for the early detection of movement. Next, visual perception. The information received by the visual apparatus must be filtered and passed to processing elements which allow us to recognize coherent scenes, disambiguate relative distances, and differentiate color. So there are three types. One is perceiving size and depth, perceiving brightness, perceiving color. So first we will see perceiving size and depth. The size of that image is specified as a visual angle. If we were draw a line from top of the object to a central point on the front of the eye and second line from the bottom of the object to the same point, the visual angle of the object is the angle between these two lines. Visual angle is affected by both the size of the object and its distance from the eye. The visual angle measurement is given in either degrees or minutes of arc, where 1 degree is equivalent to 60 minutes of arc and 1 minute of arc to 60 seconds of arc. So these lines are explained in this diagram. Objects of the same size at different distances have different visual angles. Next, if you see the below diagram, objects of different sizes and different distances may have the same visual angle. Visual acuity is the ability of a person to perceive fine detail. A number of measurements have been established to test visual acuity, most of which are included in standard eye test. Example, a person with normal vision can detect a single line if it has a visual angle of 0.5 seconds of arc. Spaces between lines can be detected at 30 seconds to 1 minute of visual arc. These represents the limits of human visual acuity. So next is perceiving brightness. Brightness is in fact a subjective reaction to levels of light. It is affected by luminance, which is the amount of light emitted by an object. The luminance of an object is dependent on the amount of light falling on the object's surface and its reflective properties. Luminance is a physical characteristic and can be measured using a photometer. Contrast is related to luminance. It is a function of the luminance of an object and the luminance of its background. Visual acuity increases with increased luminance. This may be an argument for using high display luminance. However, as luminance increases, flicker also increases. The eye will perceive a light switched on or off rapidly as constantly on. If the speed of switching is less than 50 Hz, then the light is perceived to flicker. In high luminance, flicker can be perceived at over 50 Hz. Flicker is also more noticeable in peripheral vision. This means that the larger the display, the more it will appear to flicker. Next is perceiving color. Color is usually regarded as being made up of three components: hue, intensity, saturation. Hue. Hue is determined by the spectral wavelength of the light. Blues have short wavelength, green medium, and red is long. Approximately 150 different hues can be discriminated by the average person. Intensity and saturation. Intensity is brightness of the color. Saturation is amount of whiteness in the color. By varying these two, we can perceive in the region of 7 million different colors. However, the number of colors that can be identified by an individual without training is far fewer. The eye perceives color because the cones are sensitive to light of different wavelengths. There are three different types of cone, each sensitive to a different color: blue, green, and red. Color vision is best in the fovea and worst at the periphery where rods predominate. It should also be noted that only 3 to 4% of the fovea is occupied by cones which are sensitive to blue light, making blue acuity lower. Finally, we should remember that around 8% of males and 1% of females suffer from color blindness, mostly commonly being unable to discriminate between red and green. The next is capabilities and limitations of visual processing. Visual processing involves the transformation and interpretation of a complete image from the light that is thrown onto the retina. Visual processing compensates for the movement of the image on the retina, which occurs as we move around as the object which we see moves. From this diagram, what do you perceive? The context in which the object appears allows our expectations to clearly disambiguate the interpretation of the object as either B or 13. In the first diagram, it is B, not 13. In the second diagram, it is A, B, C. In the third diagram, it is 12, 13, and 14. From seeing this diagram, which line is longer? So this is Muller-Lyer illusion. Most people, when presented with this, will say that the top line is longer than the bottom. In fact, these two lines are the same length. This may be due to false application of the law of size constancy. The top line appears like a concave edge, the bottom like a convex edge. The Ponzo illusion, or these are the same size. So இந்த ப்ளூ கலரில் மென்ஷன் பண்ணியிருக்கிறதுலாம் சேம் சைஸ்லையா இருக்குது அப்படின்னு கேட்குறாங்க. Here, the top line appears longer owing to the distance effect, although both lines are the same length. These illusions demonstrate that our perception of size is not completely reliable. So read the text. It is a correct text. This image is the proofreading illusion. What does it say? Most people reading this rapidly will read it correctly, although closer inspection shows that the word "the" is repeated in the second and third line. The quick brown fox jumps over the lazy dog. See, I missed the. So again I am read it again. The quick brown fox jumps over the lazy dog. Okay, next, the last topic in vision is reading. During reading, the eye makes jerky movements called saccades followed by fixations. Perception occurs during the fixation periods, which account for approximately 94% of the time elapsed. The eye moves backward over the text as well as forwards in what are known as regressions. If the text is complex, there will be more regressions. Adults read approximately 250 words a minute. The speed at which text can be read is a measure of its legibility. A negative contrast provides higher luminance and therefore increased acuity than a positive contrast. This will in turn increase legibility. However, it will also be more prone to flicker. So, the next input output channel is hearing. The sense of hearing is often considered secondary to sight, but we tend to underestimate the amount of information that we receive through our ears. Close your eyes for a moment and listen. What sounds can you hear? Where are they coming from? What is making them? As I sit at my desk, I can hear cars passing on the road outside, machinery working on the site nearby, the drone of a plane overhead, and bird song. But I can also tell where the sounds are coming from and estimate how far away they are. So, from the sounds I hear, I can tell that the car is passing on a particular road nearby my house and which direction it is traveling in. I know that building work is in progress in a particular location and that a certain type of bird is perched in the tree in my garden. Human ear. Hearing begins with vibrations in the ear or sound waves. The ear receives these vibrations and transmits them through various stages to the auditory nerves. The ear comprises three sections commonly known as outer ear, middle ear, inner ear. Outer ear. Outer ear is the visible part of the ear. It has two parts, the pinna and the auditory canal. The pinna, which is the structure that is attached to the sides of the head, the auditory canal along which sound waves are passed to the middle ear. The outer ear serves two purposes. The first purpose is it protects the sensitive middle ear from damage. The auditory canal contains wax which prevents dust, dirt, and over-incusate insects reaching the middle ear. It also maintains the middle ear at a constant temperature. Second purpose is the pinna and auditory canal serve to amplify some sounds. Middle ear. The middle ear is a small cavity connected to the outer ear by the tympanic membrane or ear drum and to the inner ear by the cochlea. Within the cavity or the ossicles, the smallest bones in the body. Sound waves pass along the auditory canal and vibrate the eardrum, which in turn vibrates the ossicles, which transit the vibrations to the cochlea and so into the inner ear. This relay is required because, unlike the air-filled outer and middle ears, the inner ear is filled with a denser cochlean liquid. If passed directly from the ear to the liquid, the transmission of the sound waves would be poor. By transmitting them via the ossicles, the sound waves are concentrated and amplified. Inner ear. The waves are passed into the liquid-filled cochlea in the inner ear. Within the cochlea are delicate hair cells or cilia that bend because of the vibrations in the cochlean liquid and release a chemical transmitter which causes impulses in the auditory nerve. So the second type in hearing is processing sound. Sound is changes or vibrations in air pressure. It has a number of characteristics which we can differentiate. Pitch. Pitch is the frequency of the sound. A low frequency produces a low pitch, a high frequency, a high pitch. Loudness. Loudness is proportional to the amplitude of the sound. The frequency remains constant. Timbre. Timbre relates to the type of the sound. Sounds may have the same pitch and loudness but be made by different instruments and so vary in timbre. The human ear can hear frequencies from about 20 Hz to 15 Hz. It can distinguish frequency changes of less than 1.5 Hz at low frequencies but is less accurate at high frequencies. The auditory system performs some filtering of the sounds received, allowing us to ignore background noise and concentrate on important information. The next input output channel is touch. Touch provides us with vital information about our environment. It is also known as haptic perception. It tells us when we touch something hot or cold and can therefore act as a warning. It also provides us with feedback when we attempt to lift an object. Example: consider the act of picking up a glass of water. If we could only see the glass and not feel when our hand made contact with it or feel its shape, the speed and accuracy of the action would be reduced. This is the experience of users of certain virtual reality games. In virtual reality games, they can see the computer generated objects which they need to manipulate, but they have no physical sensation of touching them. Watching such users can be an informative and amusing experience. Touch is therefore an important means of feedback, and this is no less so in using computer systems. For the average person, haptic perception is a secondary source of information. For those whose other senses are impaired, it may be vitally important. For such users, interfaces such as Braille may be the primary source of information in the interaction. We should not therefore underestimate the importance of touch. The skin contains three types of sensory receptor: thermoreceptors, nociceptors, and mechanoreceptors. Thermoreceptors respond heat and cold. Nociceptors respond to intense pressure, heat, and pain. Mechanoreceptors respond to pressure. Two kinds of mechanoreceptor which respond to different types of pressure: rapidly adapting mechanoreceptors and slowly adapting mechanoreceptors. The last input output channel is movement. A simple action such as hitting a button in response to a question involves a number of processing stages. The stimulus is received through the sensory receptors and transmitted to the brain. The question is processed and a valid response generated. The brain then tells the appropriate muscles to respond. Each of these stages takes time, which can be roughly divided into reaction time and movement time. Movement time is dependent largely on the physical characteristics of the objects, their age, and fitness. For example, reaction time varies according to the sensory channel through which the stimulus is received. A person can react to an auditory signal in approximately 150 milliseconds, to a visual signal in 200 milliseconds, and to pain in 700 milliseconds. A second measure of motor skill is accuracy. Speed and accuracy of movement are important considerations in the design of interactive systems, primarily in terms of the time taken to move a particular target on a screen. The target may be a button, a menu item, or an icon. Fitts law. Movement time is equal to a plus b log to the base 2 of distance divided by size plus 1, where a and b are empirically determined constants. If you have any doubts, leave your doubts in the comment section. Thank you.